Hello everyone, welcome to my talk on driving organizational sustainability with platform engineering. And so before we continue, I'm just going to tell you a little bit about me. So I'm currently a staff engineer for the New York Times' operation engineering org, and I'm focused on election readiness right now and observability, which sits under our wider platform engineering organization. And so as someone who's responsible for the direction of my team and is an engineering leader across all of the times, I spend a lot of my time thinking about the function of our platform and reliability engineering story and how it can facilitate success across all of the times. And ultimately, what that looks like is coming from the perspective of enabling our department to work in a way that ensures long-term organizational sustainability. And so we'll start off by talking about what I even mean when I say organizational sustainability. And so more specifically, I define sustainability as the continuous practice of operating in a way that enables short-term growth opportunities while ensuring long-term success. And so there's a lot to unpack here, so we're just going to break it down a little bit more. And so first, sustainability is a continuous practice. Even if we spend a lot of upfront time thinking about how to ensure long-term sustainability, right, our circumstances change and often quickly, especially this year in tech. And so we need continuous avenues to ensure long-term success. Secondly, enabling short-term growth opportunities. And so sometimes those risky short-term growth opportunities are what actually end up leading to our long-term success, right? The emergence of bundles of tools, for example, is a pretty common pattern now and has worked really well for some companies, including the Times. I'm sure at least some people here really love Wordle or New York Times Cooking, Wirecutter, et cetera, right? And so do we, because those were revolutionary business decisions for us. And so we don't want to give that up, but putting on my reliability management hat, we also need to prepare for the risk of those opportunities, which leads us to the component of enabling long-term success. So we frequently see companies take their core business for granted in the name of growth, but for every successful growth opportunity, right, most opportunities do fail, unfortunately. And so preparation for this type of risk is essential. And so now that we've defined the goal, organizational sustainability, let's define the strategy, which is platform engineering. And so as much as I hate repeating some words on the slide, I'm going to do it if only for emphasis. And so using my definition of platform engineering drives organizational sustainability by practicing sociotechnical principles that provide a community-driven support system for application developers using our standardized shared architecture. And so these three components form the basis of what it means to provide a platform. And so one theme throughout this talk is going to be about how platform engineering can enable us to scale our organizations to enable the growth that our businesses often demand. And as part of that, we'll need to ask ourselves, like, at what point is this platform engineering framework even necessary? Well, that's a first since I've been speaking. We frequently talk about scaling software, but what does that actually mean to scale an organization, right? And the answer is ultimately that our ability to scale our organization is directly tied to our ability to scale our software. And so when we think about scaling our software, we have to be intentional about addressing the inevitable complexity that comes with that growth. And so to address this complexity, we have to bring this intention into how our architecture can enable those needs. And this is because complexity makes development so much harder, right? Like, it makes things so much harder that we as a collective industry have evolved the way that we build applications. So for example, the modular monolith pattern has become an increasingly popular architecture style, especially as an intermediate step towards adopting distributed architecture patterns that enable us to work on and scale our applications. And so just like we've evolved the way that we build applications to embrace new architectural patterns like microservices, we must evolve the delivery strategies that we use to build these new architectural patterns. So if these architectural patterns are a solution to the technical complexity of scaling our applications, platform engineering is a socio-technical solution to the organizational complexity of scaling our applications. And so again, just to summarize it concisely, platform engineering is a socio-technical solution to the organizational complexity of scaling our applications. So we'll spend the rest of this talk decomposing each of these components even further, the principles that guide us, the community-driven support that enables application developers, and the architecture that we'll use and build along the way. And so first, we have the principles that guide the rest of our platform. And so having focused on reliability management, the principles we'll review are heavily influenced by DevOps, particularly because DevOps takes a strong consideration for both the technical and social components of what it means to develop and operate software. And so we'll start heading into those principles. So if any of us are in the DevOps space, we've probably heard of the CALMS framework, which is basically a framework of principles that should be the core of organizations, DevOps organizations. Now, while all 5 could be easily applicable here, I'm just going to focus on 3, and more specifically, culture, automation, and measurement. And so starting off with culture, the COMS framework tells us that DevOps drives a culture of continuous improvement and reduces silos by intentionally sharing knowledge and feedback. And the same is true here with platform engineering, but I'll talk about it more directly by putting in the context of community. And so in DevOps, we often talk about breaking down silos, and the way that we bridge that is by sharing knowledge. And to share knowledge really ultimately means to connect. And so connection and communication are going to be key for preventing the silos that would hinder our ability to make continuous progress. And when we're talking about organizations, especially as they grow, the most effective way to manifest this culture of sharing is to think about how we can cultivate a strong community that fosters this culture at scale. Because ultimately, right, the opposite of isolation or silos is to be in community with other people. And the reason that that's so important is because more than anything, learning is the most important sustainable advantage. So this quote is by Andrew Clay Schaefer, who is often known for being the co-founder of Puppet. And he recently said this in his talk about sociotechnical systems at DevOps Days Amsterdam. And the way that I interpret this to mean is that because our industry is always changing, being able to keep up with this change is the biggest advantage that we can give ourselves. But to do that, right, learning needs to be a core part of our organization's DNA. And so while I agree with him, I'd like to modify this a little bit to emphasize that communal learning is the most sustainable advantage. Because while our individual growth is important, if this knowledge isn't being shared intentionally, we risk introducing singular points of knowledge. And so, like our technical systems, right, humans are not supposed to be 100% reliable, and so we shouldn't be putting anyone in the position to be those singular points of knowledge, right? And this is ultimately how those silos are created. And this is ultimately how silos become an organizational pattern that hinders sustainability. And so in other words, communal learning is what provides knowledge redundancy that's needed to sustain both ourselves and the business. And so next we have automation, which improves our software delivery process by reducing human error, improving efficiency, and enabling faster delivery. And so this means thinking critically about the type of work that doesn't necessarily require business-specific knowledge, and figuring out whether that can be consolidated into software that's managed primarily by platform teams. And when we do this, right, we can reduce the required cognitive load that product engineers often have to indulge in by managing all aspects of their software. And the type of work that's important but can be consolidated in an automated or centralized way is work that's often repeatable or manual, right? Which for SREs, that might be we refer to as toil, or product engineers might refer to as like boilerplate templates. And so another aspect of platform engineering is how we should be explicit about improving efficiency by leaning into solutions built by third parties, whether through vendors or open source ones. And the reason for this is because we need to reduce our own cognitive load and maintenance just as much as product engineers do. And lastly, we have measurement. So first, we'll talk about the function of measurement, which is ultimately to have feedback loops for whether our work is actually having the intended impact. And these feedback loops should consist of both qualitative and quantitative feedback loops for continuous improvement. And the way that this principle connects to sustainability is, again, by eliminating this time spent on work that doesn't ultimately lead to our business goals or enable them. So for example, right, if we spend a bunch of weeks on a tool that isn't actually ending up serving our product engineering users, leading to lack of adoption, we've now invested time that could have just directly served our paying end users. And so we end up missing the ultimate goal, right, of building applications that age well with our evolving product growth opportunities. And so, in other words, these feedback loops just keep us on the right path towards the continuous improvement that enables us to build new features while maintaining our existing software in a sustainable way. So now that we've defined some principles, we'll shift over to talking about support strategies for application developers who are integrating with our platform. And so I'll speak to both scalable and flexible strategies and put it in the context of the ways that we measure success, consolidate efforts, and cultivate a culture that values sustainability. And so the first is the most scalable strategy of all, which is to make building sustainable software easy. And so we'll dive more deeply into this in the next section when we talk about the actual architecture. But to set the stage for that, let's remember from earlier that sustainable organizations are directly tied to their ability to build sustainable software. And I'm sure that we've all worked with software that clearly wasn't built with much foresight, right? This is what we usually refer to as tech debt. And tech debt is obviously inevitable, but we can mitigate its risk by being intentional and strategic about when and where we inject tech debt. And so ultimately, right, like tech debt should have a function, usually for the purposes of these like short-term growth opportunities, and tools that aren't easy to integrate with are a type of technical debt that typically doesn't end up paying in the long term. And so it's especially our duty as platform engineers to build easy-to-use tools to minimize the time that we spend needing to support application developers. And so now that's not to say that we shouldn't be willing to support developers, right? Like the opposite is actually true. Just because platform engineering is supposed to make domain boundaries clearer and decouple product development from supportive tools doesn't mean that we get to just stop talking and working with one another, right? And I know as engineers, right, we often have an aversion to social interaction, but people are supposed to interact with each other. And I think the pursuit to make everything self-serve is often more harmful than it is helpful. And so what we really need to do is be intentional about when the right time to support is and how we can leverage a culture of communal learning and support so that platform engineers are not the singular points of failure that I mentioned earlier. And so not only does this alleviate some tension on platform engineers, but it also enables us to be more community-driven in the way that we support product engineers. And so I talked about measurement as a principle earlier, and an important measurement of our effectiveness is often the adoption of our developer platform. And so what intention looks like here is ultimately defining the way that we approach support and clearly communicating it to avoid mismatched expectations that will end up degrading trust between platform and product engineers. And so in the interest of time, I'll just provide one example of this, which is to provide an easy decision framework, which is driven by the status of your tool. And I don't have enough time to review, but feel free to take the 3 seconds to take a picture while I drink some water. So, excuse me. A common pitfall for platform engineers is to take on too much platform integration work. And so like the last slide showed, right, there is room for that, especially in the earlier like experimental modes, but that's not scalable and therefore not sustainable, nor are we often even the right people to be doing that type of work of integrating our tools into applications that we don't own or have context with. And so, an example here might be like testing. Platform engineers can certainly create or recommend testing tools or methods, but we shouldn't be the ones writing a unit test for some random service that we don't own, right? That's ultimately requiring domain knowledge. And luckily, if we're doing our jobs right, like the time that we save them by providing support does free up their time to actually take on that more application-specific work. And lastly, driving a sustainable culture. So sustainability doesn't just apply to software, it applies to people, and the two are often very closely tied. So referencing Accelerate, which is a common book in the DevOps space, it talks about self-sustainability and the different types of burnout to look out for, whether that's physical or emotional, et cetera. And so because platform engineering naturally touches many, if not all, parts of our organizations, we have a unique opportunity to show what it looks like to operate in a way that achieves excellence without sacrificing people along the way. And so our work gets to be naturally collaborative and can impact so many parts of our organization. And so we should drive a culture of intentionality forward with everything we do and lead by example. And lastly, we have our platform architecture, which is the architecture that platform engineers are building to support application development. And again, the function of this architecture ties directly to the first support strategy that we talked about, which is to make building sustainable software easy by reasonably and intentionally consolidating efforts and cognitive load. And so we've already talked about the high-level principles, but now we're going to review architecture design principles. And so the first is to embrace design-driven architecture as a core set of best practices, right? And so intentionality should be an important attribute of the way that we build technology and collaborate with others. And this intention should manifest in the way that we design platform systems, whether that's to use abstraction or modularity to separate different functional concerns. And this principle can be broken down into many pieces, but for now I'll omit that because we'll talk about this more when I talk through some design tensions and how to alleviate them in a few minutes. Secondly, our architecture should be complementary to those of our users. Now, that doesn't mean we shouldn't try to anticipate developer needs, but there is a value in thinking about where our platform architecture might be heading. But to the last principle on intentional design, we need to design with the future in mind and not necessarily always build for it immediately. Much in the same way that we might design a monolith application in a way that would allow us to decompose it into a distributed architecture in the future. And so when we prioritize our work, we should be driven by the needs of our application developers in our organization, whose architecture should be a reflection of our paying end users. And so this might mean deprioritizing and prioritizing certain domains, whether that's CI/CD or observability or runtime language support. And so this is why, for example, at times we have an observability-focused team, but I don't actually always expect that to be the case. Our organizational structure is really informed by the needs of our actual developer. And within those domains or problems that we're trying to solve, we'll also need to build in a way that's responsive to evolving architecture and developer needs. So for example, right, if we want to improve the runtime experience for developers, we should prioritize the languages that are actually being used by them, not ones that we just want to use, right? And this is because ultimately we're not here to tell other developers what to do, we're here to support them in what they need to do. And another reason that this is important is because our platform architecture can easily lead to what I would call platform chaos. Every time I go on this slide, it gives me, like, my fight or flight response just kicks in, right? And like, we don't want this, right? We don't want to live in a world where we have 10 tools or platforms or whatever you want to call this for any given thing that we need to do, right? This unnecessary drift is painful and it's unproductive to our development cycles. And so ultimately, right, like an overwhelming number of tools, especially ones that are customly built, is not the goal. Tools should just be enablers of our goal to build successful engineering organizations. And so instead, what I like to think of us is as managers of chaos, right? And the way that we do that is by aligning the components of our developer platform with specific domain use cases. And so this enables us to design our platform so that we can see the similar benefits of concrete separations of concerns that we often see in end user-facing architectures. And this is where I'll take a moment to talk about a common pitfall that we see within platform engineering as well, which is that platform engineering is not equal to infrastructure platforms. Right? I'm going to say that again, actually. Platform engineering is not equal to infrastructure platforms. And I think this is part of why, if you're familiar with DevOps and keep up with it, right, we see a lot of naive conversations around DevOps being dead in lieu of platform engineering. And this is because many of us are operating under the assumption that the only shared platform that companies need is ones that are limited to infrastructure. But, for example, right, we should also be thinking about how platforms can aid service or feature development cycle during the actual development phase, for example. And so this might mean having runtime language, platforms that support the development of standardized Node.js services, for example, if that's what your organization's choice of language is. And each of these, right, can like be decomposed even further. But again, tying right to principle number 2, this decomposition should only happen if there's a genuine need for it. And so, for example, if your organization decides to introduce a new standard language, then that's a good moment to decompose your runtime platform further. And in the infrastructure platform context, right, you might also see this that further broken up into domains like cloud infrastructure or CI/CD and observability. And the same technique that we see, and the same techniques that we see in domain-driven design are ones that we can reuse in the platform context too. For example, my organizations in the past have done like event storming. We actually just recently did this to inform a reorg. And then also to complicate this even further, there are even product platforms, which might refer to like specific end user product domains or a core platform, though you might also see this as like core services depending on organizational structure. And lastly, choosing boring technology. And so this ties back to when I spoke about not building tools from scratch. And we can prevent that by not leaning into every cutting edge opportunity, right? So some years ago, a blog post named Choose Boring Technology by Dan McKinley went tech viral. And he talked about this idea of innovation tokens and how we need to be intentional about where we spend those, right? As engineers, we like love to play with new toys. But every proof of concept shouldn't be making it to production, right? And I acknowledge it's tempting, especially because there's a lot of organizations there building a bunch of new tools like CNCF. But recency bias shouldn't be driving our decision criteria, it should just be informing it. And one of the most seen as boring technologies are docs. And so this might be a hot take, but I think too many internal developer platforms could probably be replaced by good best practices and standards docs. And like, obviously it's not as exciting, right? But it's still work that enables us to learn and mature the ways that we build technology. And even if months or years later we decide that we do need a new tool that we need to build, it's still often not wasted effort because they often end up being a pretty good start for design and requirements gathering anyway. And so I mentioned earlier about some design tensions related to architecture best practices, and so these are what we'll review next, including a framework for how to address those 4 primary tensions. And so first I have what I think is the hardest tension to balance, which is standardization versus flexibility. And so the shared nature of a developer platform, right, is like an awesome opportunity to reduce the risk of drift. But we have to hold that intention with the flexibility that developers might need, especially as our organization grows and the number of technical needs grows with it. So for example, like my organization right now is facing the consequences of building tens of services with an opinionated framework that has since not aged well. So now not only do we have to revisit how we approached runtime support, but now we also have to reconcile the tech debt that manifested from this decision years ago. And so that said, reflecting on where we went wrong, but what we're doing now is to engage with our users more. And so I started off this talk, right, by saying that the opposite of isolation is community. And so now the way that we're approaching it is from the standpoint of driving standards with actual teams and our communities of practice. And by doing this, like, we have built-in buy-in from our teams because they ultimately had input, and everyone loves their code and opinions more than others. It's the truth. And next, we have the tension of simplicity and complexity. And so as you respond to the evolving needs of your users, complexity becomes harder to manage because the architecture that supports them is likely to change, and whether that's to begin using event-driven communication patterns or begin embracing client-side rendered front ends. And so this just becomes another area that we need to be intentional about. And so like tech debt, right, like complexity is inevitable, but we can compartmentalize it somewhat by making sure that our developer-facing interfaces are simple. And so this leads us to the most common source of complexity in software engineering, which is integrations. And so we know the common design principle of reducing coupling between services, right? And the same applies to this work. Integrations are high risk for us because avoiding coupling is incredibly difficult, right? That's why a huge selling point for vendors is often their integrations, and that's so that we don't have to think about it anymore. And so speaking of vendors, remember our automation principle from earlier? Even though I just spent some time talking through design principles for building platforms, I'm also here to say, like, give yourself permission to not build at all. The decision to build versus buy versus reuse should be our bread and butter, and deciding that we don't want to take the risk or the work of building and maintaining a tool is a very valid one because, as one of my brilliant mentors once said, every line of code you write is a liability. Right? Code isn't necessarily our bread and butter of platform engineering. Research, design, and technical decisions are. And so engineering is a craft, that's why we're all here, and we should treat it as one. And so holding all these tensions in mind, let's talk through what I'll refer to as a platform framework. And so this framework is a reusable framework with 4 pillars or parts, and this allows us to enable, compartmentalize, or communicate the trade-offs of the tensions that I just talked about. And together they make up the ultimate developer platform architecture. And so we'll briefly review each of these pillars and then provide some more concrete examples. So first, we have the parts of our architecture that provide standardization. And so 2 examples of how we might do that is through templates or opinionated frameworks. Secondly, we have the parts of our architecture that provide more flexibility. And so, for example, right, like we might design our framework to be more modular so that developers can pick and choose just based off the context and their needs. And thirdly, we have the parts of our architecture that compartmentalizes complexity through integrations, since the first 2 pillars reflect the simple developer-facing interfaces that I mentioned earlier. And so this might be APIs that tie the first 2 pillars together, or plugins to front-end interfaces that developers use to just provide visibility of like what tools they have to use. So these tools are usually not actually used directly by like the product engineers we're building for in their development, and are actually instead tools that we usually use to support developers in a more automated way. So for example, right, like the tools that pool our technologies together to support on-demand environments, right? Like product engineers are certainly going to use those environments, but the technical details of how we implement those should be abstracted away so that they can just focus on product development. And lastly, we have the parts of our architecture that communicate our design and decisions along the way, whether that's through API docs or architecture design, decision records for when we decide to build versus buy versus reuse. And so it might be kind of strange to like include this as part of our architecture, but as I've emphasized throughout this talk, right, like touch points between product and platform engineers is essential, and this is just one of the ways that we can do that. So documentation is like the first obvious one that I'm sure we can think of, with support channels as a complementary. There's also a potential need for automating certain aspects of our support as we scale up the number of engineers that we're supporting. So for example, right, like if our primary communication tool is Slack, integrations that consolidate questions and feedback centrally can enable us to have more feedback loops that can be really valuable in avoiding like adoption issues later on. So in the integrations pillar, I mentioned plugins as an example to provide visibility of what tools exist. And that's an essential question to answer because visibility is what we need to drive adoption. And so we'll answer that question next of how to provide visibility into our architecture. So especially with the emergence of Backstage, which is an open source project that's created by Spotify, developer portals have become a way to provide centralized visibility into the developer platform ecosystem. And so the concept of a developer platform portal is a compelling one because ultimately it tells the story of what it means to develop software at your company. And so by providing this unified view, not only does our platform become visible, it also facilitates visibility into any service that's using the portal. And so integrations are going to be a crucial part of developer portals, but because it's a centralized entry point, we do have to consider the risk of a singular point of failure. And so this is why it embraces the idea of plugins, which are designed to be easily added or removed from the host application without total coupling. And so in other words, just like we saw in our principles, it provides similar benefits that we see as with microservices by having concrete separations of concerns. So for example, at the Times, we actually have a very, very hard requirement that anything that's integrated into Backstage must be able to stand on its own because we don't want it to be any kind of centralized point of failure. And so now that we've covered some of the fundamentals, let's move on to the more concrete examples that I've worked on in the past. And in the spirit of showing that platform engineering is not just about infrastructure platforms, like I mentioned earlier, we'll walk through 3 examples that reflect the story that I mentioned earlier, the story of what it means to develop software at your company. And what that story ultimately looks like is centered around the feature development cycle. And so in the interest of time, I won't go through each of these. All you really need to know is that this is the story that we're ultimately telling, the one that's surrounded around our feature development cycle. And the ones that are most relevant to us today especially are the development, production readiness, and delivery stages. And so those are the ones that we're going to focus on for the rest of this time. And again, in the spirit of showing that platform engineering is not just about infrastructure, the 3 examples that we'll review will include one on language runtime platforms, the second is on infrastructure runtime platforms, and the third is on full stack observability. So starting with development, which provides end-to-end product development, which supports the end-to-end product development cycle, particularly runtime and architecture needs. And so this phase usually manifests in language runtime platforms, and so we'll review one that's based on Node.js runtimes. So for the first part of our framework, we embrace standardization through runtime language templates, which minimize the repeatable or boilerplate code by centralizing it into a template. And so what this might look like practically might be a simple server file like this. And so this template file not only provides a reusable file, but it also acts as a standardization technique by including our organizational framework of choice, which is Express. And from this, right, developers would only need to modify the parts that need service context highlighted here. And over time, right, we could extend templates to also include other standards for other tools and dependencies like package managers or linters or testing frameworks, which can also be reflected in JSON configuration files. And when beginning to build these templates out, right, like we should generally start simple and build our way out. because rushing into their development too quickly can lead us down a path where we're building towards a developer story and targeted paths that don't actually end up serving the product engineers. Now, there are a lot of problems with with templates, right? It's really hard to maintain like version control. It's really hard to address like drift when it happens. And so alternatively, what you might decide to build is a runtime framework that codifies organizational standards. So unlike template files where it's very easy to just change the code because it's directly in front of you, versus a framework obviously abstracts that away. And so it's a better way of enforcing any standards that your organization might have. So you can imagine, again, as like your organization grows, its standards, right? That server template can also quickly become overwhelming, right? It could quickly become very long. And so, for example, like if we want to extend our functionality to include middleware or standardize how we write APIs, and again, as we add more and more to these template files, it's probably going to become impossible for developers to even figure out what's being provided for them. And like, sure, comments can help, right? But there's a reason, again, that we use abstractions. And so in an effort, again, to keep that template simple, we'll abstract those away and and replace the express code with our own framework. So here's what that package code might look like, as well as a simpler server TS file that we now would be providing. Now, there are, of course, also many downsides to this, right? This is a fairly large dependency introduction. I think I even mentioned earlier about us having to reconcile the framework that we started to adopt years ago. We now also have to maintain this code for years, and so it's a commitment that we can't make lightly, and it also requires a huge amount of intentional design. But it does address drift a lot more effectively because, again, those templates are easier to change versus frameworks actually abstract implementations from the interfaces. And so that's the part that really makes the difference between whether your framework ends up being a sustainable solution, right? Is the implementation of your framework genuinely abstracted from its interface? Because that abstraction is what enables us to iterate on unforeseen pain points and avoid breaking chains or deprecations. Now, I've seen frameworks primarily work for organizations that adopt platform engineering on the earlier side, actually, and more specifically during that transition period when we've decided that a monolithic application isn't no longer working for us anymore, and that decomposition needs to be a reality. And this is because once we've already gone down the distributed systems journey, addressing drift with the framework is really tough to justify to service owners. Because at this point, that service was probably already built in a really opinionated way. And so reconciling the drift in software and people's opinions is often a tedious process that doesn't end up paying in the long term. But again, if we start to build our platform before we're down that distributed systems rabbit hole, it can actually set us up really well for successfully decomposing a monolith, since the repeatable tasks that, like making your service observable, that we need to do for each service can just be abstracted into that framework. Now, when frameworks or templates aren't the right path forward for your organization's needs, but we want to provide some more flexible options, runtime packages are a great tool in our framework, in our platform framework. And so here we have a lot of decisions to make also, including where on the spectrum of flexible we want to be, because they're obviously not a binary. And this is because these packages are still an avenue where we can inject standardization as well. And so to ground this again in an example, right, we might have this naive example or naive function in here that is related to authorization that we might want to have a standard for example. And in this naive example, the standard is that we want to have the header value be all uppercase for whatever reason. And while this function is opinionated, unlike a template or a runtime framework, this functionality is opt-in, meaning that while we want to incentivize developers to use it, we can't actually require them to. An additional benefit of modules is that should we ever revisit the possibility of building a centralized framework, we'll already have some building blocks that we can use to assemble this ultimate framework. And so for organizations that are outside of that initial transition period between the monolith and distributed architecture, building modules is often a great first step when adopting platform engineering, because it allows us to incrementally build for the needs of our developers without investing the huge amount of time that frameworks often require. And so now we'll move on to the next pillar of the framework, which is integrations and plugins. So extending on our example, As our organization grows and the architecture evolves, so might the number of packages. And developers will need visibility into these different packages, so naturally we're going to probably decide to integrate with a package manager and repository, which should be managed centrally again so that it has clear ownership and so that it doesn't become too bloated with packages or artifacts like our templates. And conveniently, there might even be a plugin available for our developer portals so that it's even more visible to them. And along the way, we'll need to document our work so that our users can use our tools more smoothly. And combining this with our second principle from earlier, finding ways to automate this will make our lives easier and set us up for our docs to be less stale. And so for Node.js, this might mean integrating with TypeDoc to automatically generate them based off of comments, which might then plug into our developer portal to render the documentation there. And so next, we'll focus on a platform use case related to infrastructure runtimes. And more specifically, I'll focus on the container runtime experience. So reflecting back on the 4 pillars, we embrace standardization here, the first part of the framework, through base templates and images, which minimize repeatable code and configuration by centralizing it into a versioned template or image. And here, like, that versioning part is really critical, especially for templates, because it's very easy to fall back into the trap of drift, like I mentioned earlier. Now, when these first options aren't the right path forward, but again, we still want to provide more flexible options, standard image artifacts are also a great tool in our platform framework. And again here, like, we have to make the same decisions that we saw earlier, like where on the spectrum of flexible we want to be, we want these artifacts to be, or whether we want to require them versus just like recommend them for developers. And next, the integrations pillar, which represents either the integrations between components within this platform or integration between multiple platforms. And so what this might look like in this context is our template generators for Docker file or Docker Compose files versus like the integrations between a container runtime platform and a Kubernetes platform. And lastly, all these different components and decisions can quickly get overwhelming, even when designed with a lot of intent. And so not only do these decisions need to be reflected somewhere, we also need to understand that infrastructure incidents are ours too, and that the process of incident management should be one that fosters collaboration and knowledge sharing, which was a value that was reflected in the principles earlier. And so what this looks like can be a little tricky depending on whether you have an SRE org and their specific operating model, but regardless of the organizational structure, driving clarity over what incident management support looks like is crucial to avoiding broken trust when our platforms inevitably fail. And part of that is also making sure that product engineers are set up to effectively differentiate when a production issue is due to infrastructure versus application issues. And lastly, we have a more specific domain use case for a platform, which is observability. Now, when it comes to production readiness support, this work often builds on top of existing platforms, actually. That's why it's actually a little awkward that the SRE org is under platform engineering, and you'll see why. So going back to the build versus buy versus reuse tension, let's say that we use OpenTelemetry, which is a standard within the observability space, after considering the trade-offs of defining our own standard, using one from open source, or using a vendor-specific one instead. And given this decision, we choose to embrace standardization even further by adding a new config in the values YAML template to support the standard. And an important thing to note here is that this technical decision reuses a technical decision that was made, for example, by the infrastructure platform team to avoid introducing unnecessary drift. So as an SRE org, for example, you actually end up contributing to other people's platforms. And again, what we're doing here is really just extending their platform to just support reliability and, in this context, observability needs. So the impact of that is developers don't have to worry about managing config needed to use the theoretical OpenTelemetry collector that we decided to provide. And instead, they can focus on instrumenting their applications for telemetry that does require service context. And so switching gears into more flexible offerings, we choose to extend our runtime platform to include modules that provide features that are relevant to telemetry collection. And so that might mean providing an optional middleware function to enable telemetry collection. And so in this naive example, we see a similar tension earlier, where we standardize the key of an attribute, but provide some flexibility by managing the values through environment variables, for example. Now, I mentioned that our work needs to align with the needs of our product engineering peers, right? And so let's say that our product has become really successful, we're solidly in distributed architecture space, and now our product teams require having new technical requirements that require them to be very cautious about any performance indication. And they also need strong concurrency support, and so our organization decides to introduce a new standard language, Go. Now, that makes our lives as platform engineers more difficult, right? That means we have to support another language. But we shouldn't meet them with reassurance or with resistance all the time, right? We can provide feedback as peers. Perhaps that decision doesn't need a lot of pushback. But being dogmatic about our targeted path too much isn't a recipe for success either. And so now we have to think about about Go development. And so using the observability example, that means we need to think about telemetry collection, what that looks like for Go. And so since we already use OpenTelemetry, we reuse that decision for the sake of consistency, except now we come across this, currently work in progress, right? And so what do we do here, right? We know telemetry collection is important, right? Like how else are we gonna debug our systems? Do we rely on older methods of collection, manual instrumentation? That could be one valid conclusion, and perhaps the most practical, but this is where I'll take an opportunity to give a brief nod to open source. Right? Our second principle talked about the role of automation in our work and how one form of that is to replicate the duplicate work that often happens in engineering. And more specifically, I offered the solution of deciding when to build, buy, or reuse existing open source solutions. And part of the reason for that is because otherwise we'll end up spending a lot of unnecessary time reinventing the wheel, but also because we have to admit to ourselves that sometimes other people are gonna do things better than us, right? And that doesn't mean that we're any less of an engineer, right? It just shows that we have humility and appreciation for the work of our peers. And so we can't be experts at everything, rather, right? And like I said earlier, engineering is an underrated way to build community, and it doesn't have to even be isolated to our companies. And so bringing back to the observability example, right? We know that there's a ton of smart people here already, so clearly so much to learn still. But given that community-driven support was a central theme to our previous section, right, we don't always have to just try and learn and build things in silos, right? Like we can learn and contribute to the communities that are already doing this work, because as much as the sustainability of our organization is tied to our ability to build sustainable software, the sustainability of our organization is also about our industry's collective ability to learn together and grow and make progress together. And so moving on to the third part of the platform framework, we choose to extend our CI/CD platform integrations to include application metrics that will allow us to have automatic rollbacks that minimize the risk of change. And again, this is an example of how reliability management is often complementary to other existing platforms. And lastly, best practices and guidance documentation. Especially because observability is such a full stack problem, everyone is going to need to think about telemetry collection. And we need to leverage that collective knowledge, put it in context with our work, and then communicate what that looks like back to the other engineers so that we're all aligned in how we approach this problem space. Oops, sorry. So to wrap this up, I've made parallels between DevOps and platform engineering throughout this talk. And I hope it's obvious more than anything that how important DevOps has been to this discipline, much in the same way that it has been for SRE, right? Like our systems are complicated because people are complicated. And much like architecture design, this type of culture doesn't just happen, it requires intent. And the most compelling part of DevOps is ultimately the way that it transforms our culture to be one that fosters exactly that, intent. And so I started off this talk by saying that platform engineering is a solution to building sustainable organizations, but perhaps the solution that we all really need is actually just intent. Thank you. Can I? Or is it where I know we're at time?